There's another example of a chemical reaction I'm going to balance. This is a single replacement reaction where the copper is going to come in, knock out silver, leave silver by itself as an atom, and then produce a compound called copper nitrate. So let's begin with our checklist. I'll list the elements. I got silver and copper listed, but one of the little tricks that I found to maybe save me some time is I noticed that NO3, a polyatomic ion, is listed here. It's not separated, and then it's listed over here as, again, a polyatomic ion. So I can almost treat it like a single substance. So I'm going to list it as NO3 and treat it as if it were an atom. Okay, let's begin. I've got two NO3 groups in the product of copper nitrate, so I'll put a 2 here. In this compound, silver nitrate, I only have one NO3, so let me put a coefficient of 2 in front of that. That makes the NO3 groups even, but as soon as I did that, I changed the numbers of silver. So I'll put a 2 in front of Ag on the reactant side, and then I'll come over here and I got to get 2 in front, 2 for silver, so I'll put a 2 in front of the Ag over here. That matches up to silvers. They're even. Then I look at the copper. There's 1 here. There's 1 on the other side, so we'll put 1 and 1. And then my final coefficients that I'll put in will be a 1 in front of both of the coppers. And there's my reaction, completely balanced. And the count of the atoms and the ions actually is even on both sides. Let me pause the video and show you a few more. This next reaction is one that a number of you may have seen as a homework problem. I'm going to work through this in the stepwise process also. Let me list our elements. I've got a barium. I have hydrogen, oxygen, and then there's a SO4 group that's the same on both sides, so I'm going to treat that as a polyatomic ion. I'll list it as a single kind of substance, SO4. All right, I'm looking at the H and the O over on this side. I notice that there is 2 and 2 hydrogens. That's a total of 4. So I'm going to put a 4 in front of the H atom. Then I come over to the product side. I have H2O. There's no other type of hydrogen there, but I need 4, so I'll put a 2 in front of the H2O. That gives me 4 and 4 hydrogens. I'll look at the oxygens next. There's 2 times H2O, or 2 oxygens here. There's a subscript 2, and then inside the parentheses there's an oxygen and a hydrogen. With the 2 on the outside, it affects both the hydrogen and the oxygen. So that means I have 2 oxygens here and 2 oxygens here. They're balanced. So I'll put a 2 and a 2 to show that they're the same. There's an SO4, a group, polyatomic ion. In the sulfuric acid here, there's an SO4 and the barium sulfate. They're even, so I'll put 1 and 1 for the SO4 group. I'll put a 1 in front of the barium sulfate. That gives me 1 barium over here. And then I come onto this side. There's only 1 barium in the barium hydroxide. I'll put a 1 in front of that. That matches up and gives me an even number of bariums. So my coefficients for my reaction now are a 1, a 1, a 2, and then a 1. That would be the numbers of moles also, how many of that particular substance I would have, either an atom or a molecule. And I'll show you a couple more. The next reaction that I would like to do is one that comes from our textbook. I know for some of the guys in my class, it was a homework assignment, a number of problems that were on the bottom of page 353. This happens to be problem number 5A. I'll list that over here, 5A. You can always go back and check that if you wish. I'm going to start off by listing my atoms: iron, chlorine, sodium, and then I notice there's an OH here, an OH here. They're not separated, so I'm going to treat those as a polyatomic ion and just list OH. Save myself some time. I'll come back and I'll look at how many elements we have. I've got 3 chlorides on the reactant side, so I'll put a 3 in front of Cl. I go to the product side. I've got NaCl over there. There's only 1 atom showing, so I'll put a 3 in front of NaCl. That will mean I have 3 chlorines here. Put a 3 in front. Put a 3 with that chlorine. As soon as I put the 3 in front of the sodium, that gave me 3. In front of the 3 sodium chloride, that gave me 3 sodiums. So I'll put a 3 in front of the Na here. I come back over to this side. There's only 1 listed. Let me put a coefficient of 3 in front of that. That gives me 3 NAs on both sides. I look here at the iron. There's 1. Reactant side has 1, so I'll put a 1 in front of each of those. And then the final thing is to look at the OHs. My OH group here, I look on the product side. There's an OH in parentheses with a 3 outside of it. That means I have 3 OHs in that compound. So I'm going to put a 3 with that OH. And I come back to the product, or the reactant side. I have a 3 in front of NaOH, so that means I have 3 of the OH groups on this side, and they're balanced. Put a 3 there, finish off with the 1 atom of each for iron. And there's my answer for problem 5A, page 353. And I'll try to show you a couple more. At this point, you might be starting to get the idea of, okay, here's the steps I can follow in order to balance an equation. So this last reaction I'm going to do for you is one that's a little bit more complex. It's one that you got to really look at a couple of times before you begin to see how you can put the atom count together. This one, I'm not going to quite break up into polyatomic ions, although you could. I'm going to try to treat this one as individual atoms. All right, let me list them. I got an iodine. We've got Na, sodium. We've got 2 sulfurs here, 3 oxygens. Over on the other side, I got sodium, sulfur, oxygen, an Na, and an iodine. So both sets of product and reactants have all the atoms listed for us. I'm going to start off by looking at the S2O3, and then over on this side, S4O6. Well, as I look at it, I can see that S2O3 could be doubled and give me S4O6. So it looks like if I put a 2 in front of this sodium, then I can have 4 sulfurs and 6 oxygens. So let me write those down. I've now got 4 sodiums here, 4 sulfurs, and 6 oxygens. Let me go to the product side. How many sulfurs? Right up here, S4, there are 4. How many oxygens? O6, there are 6 oxygens. Na, we have 4 on this side. I have only 1 over here, so let me put a 4 in front of this. It gives me 4 NAs. They're even on both sides. But as soon as I did that, I made 4 iodines on the product side. So I'll put 4 with the iodine here. I come back over to the reactants. I've got a 2 with the I atom. How can I get 4 out of that? I can put a 2 in front of I2. That gives me a total of 4 iodines on each side. So 2, 2. I can put a 1 in front of this. equals 1 and 4 as my set of coefficients. So this problem was just a little bit more complex, but again, I can take it in steps and try to piece the items together to make them even. When you're doing balancing equations, you're going to find sometimes you got to experiment a little bit, play around with it a little bit before you start to see the pattern. I find this little atom bookkeeping process a good way for me to kind of compare the atoms on both sides, and it helps me figure out which coefficients to put in front of which elements. So that'll give you a sense of the stepwise process for balancing equations, and I hope this has helped you.